Hello and welcome back to the Data Unite channel. Today we are going to understand how to implement the Decision Tree Classifier machine learning model on a real-world dataset where we are interested to predict whether a person will open a bank account if the bank targets that person during its marketing campaign. As you can see, I have already imported the necessary frameworks that we're going to use for this exercise, which are Pandas, preprocessing, SK standard scaler, training and testing split, also our model, decision tree classifier, and classification report, which will be used to see the performance of our model. So the first thing that we need to do is to import our dataset, which is done by using the following function. So pd.read CSV, and I'm gonna use the banking CSV file. Now let's see our dataset. So we'll see only the first 5 rows. As we can see, we have both numerical and string values into our features, and this will be managed as we go, because our model does not accept string variables or string values. It accepts only numerical values, so we'll have to change these values into numbers. Now let's see the shape of our dataset. Okay, and now let's do a bit of pre-processing. So first let's see if we have some. So I'm gonna do pre-processing. I'm gonna input this markdown. Let's see if we have some null values first. So df dot is null sum. So as we can see, we have all of the features don't have missing values, which is good, because if we had, then we would have to manage this. But since our model is decision trees, this model can overcome missing features, so we don't have to do that operation. Now let's see if we have some duplicates. So df dot duplicated, any. Okay, so this means that we have also some duplicate rows, so we can just drop them. I'm gonna save these results here, and now if we do df.shape, we should have less records. Yeah, we have 12 records less from before. This means that we have dropped 12 rows which were duplicates, which might have impacted on our result. Next, we need to do some the next type of reprocessing, which is changing our values into our categorical values, so our numerical values, into numbers. So we will introduce the label encoder method. So for that, first let's see what are the data types of our columns. So as we can see, we have integer, object, which are string, and then we have also float. This means that we can split our dataset into numerical and categorical. So for that, we'll do the following: none equals df.select d types, and we are going to exclude all the features or all the columns that are of type object. And for the categorical, we're gonna include okay, select underscore the types, include. Okay, and now we're going to implement, so we're gonna first initialize our label encoder. So we do pre-processing, encoder, and then we're gonna apply it. So le underscore cut. I'm gonna save the result into le underscore cut, which is label encoded categorical features, and I'm gonna apply the label encoder by fitting and transforming our dataset. So now if we print our le cut, we have all of the values with numerical values instead of previously they were strings. So for job we had string, now we have numbers. And the last step that we need to do is to concatenate again our numerical and categorical features into one dataset so that we have all the information into one place, and then we will continue with our operations. So again, we're building our data frame, so df.pd concat, and first I'm gonna put the le underscore cut and then num on the axis. Okay, so we need to add axis equals to 1 in order to tell that the concatenation will be done by columns. If we put 0, then it will be concatenated by rows, so it will be appended on the end. So we'll first have all the records from the le concat, and then under that will be added all the values from the num data frame. But in that case we need to have also the equal number of columns, and also they need to be called the same. And if we don't specify this, then we will concatenate these values diagonally. So we will have first all the values from the categorical, and then nulls and nulls, and on the diagonal on the right we will have all the values from the number category, numbered data frame. So we do our concatenation, and let's see what we have. Okay, we have all of the columns. We still have 21 columns. Our dependent variable is y. This is the one that is that's gonna be predicted at the end. It's a classification problem, so we have class 0 or class 1. Then we should just split our dataset into dependent and independent features. So dependent feature in our case is y, and independent are all the rest of the features or columns into our dataset. So we will just do x.df drop, and we are gonna drop y, and we are gonna define y as df.y. Good. Then, as a best practice, it is good also to normalize our values. So basically to bring all the values into our data frame to be in one range, which is equal for all of the values into our data frame. And for that we do the following operation. Yeah, so call x.columns. I'm gonna define the scalar, and I'm gonna scaled fit and transform x, and then this should be also transformed into a data frame because the output of this is an array, so it's not gonna be easy for us to understand. It's not a problem for the algorithm because the algorithm will read the array as an input. It's not a problem for it, but it's important for us because when we want to see the data, it would be difficult for us to understand which column and which value correspond to each other. So for that we do fields and columns false. Okay, so let's see first what will happen if I do x scaled without transforming it into a data frame. Yeah, it's a numpy array, so you cannot see it, but we can do like print. Maybe it will work. Yeah. So if we don't transform our scaled our outcome from the scaling of the x data frame, we'll get this outcome here. So you see it's a numpy array which is consisted of lists in a list. So in order to avoid this, because you can see we cannot even find the names of the columns, we cannot find all the values and so on. So for that we are performing the toDataFrame operation. Okay, it's not calls, but it's call. Okay, now we have that array transformed into a data frame, and now it's more readable for us. If we didn't want to do this, then we could have skipped this step, because the model would be able to recognize also that input and then to perform its calculations normally for itself. Now let's create our model, or all the steps for the creating of the model, and also preparation of the data set, of the data sets of the data frames that are gonna be used by the model. So model creation. So our first step is to split our x scaled and y into training and testing datasets. I think that you have seen this many times, so I'm just skip over it. Test size for me is always 0.3. Let's put it 0.4. It's up to you. If you have a huge data set, you can also go 0.5. That way you can cover more cases while doing the training, so that maybe you will have your model trained better. Let's go with 0.4. When you're doing these types of operations, you have to try different ways. That way you will be able to understand your data, you will be able to understand your model, you will see if your model wants more data, less data, and so on. So once we have our data split into 4 data frames, 2 training and 2 testing, meaning that we have X-train and Y-train and X-test, Y-test. Now let's create our model. So let's initialize our model, which is decision tree classifier in this case. Because as we know, decision tree, there are classifiers and regressions. So because it can be used for both classification and regression problems. And we have to specify that it's gonna be classifier into this case. So we do model fit and y decision tree class. Okay, let's see what's okay, I had a typo. Okay, and now we also trained it. So now let's do a prediction. So y red is going to be model dot x best. This is going to be stored into ypred. And now in order to see if our model performed well and classified the records into the X-test correctly, we can see it by using the classification report. Y-test and ypred. Okay, so we can see that our model performs well into classifying the records that should be classified with class 0, but its coin toss probability with classification of the records that should be classified with class 1. Let's change our train dataset into 0.3. No, this is the test size. Okay, so this way will increase our training. Before it was 60%, and now it's gonna be 70% for the training dataset. Yeah, we didn't gain any. We didn't get any better results, so this is something that should be then managed by inputting some hyperparameters like limiting the branching of our tree, or so basically limiting the depth of the decision tree. This can be only one case, and then we can also decide on the splitting, on how many features to split and so on. But anyway, we can also try different measures, so we can see the accuracy. So of decision tree is gonna be okay, 2f format model score. Okay, the accuracy of our model is around 90%, which is not good. As we can see, as we have seen here, it's not good. So the this value here is equals to this value here, the weighted average. Okay, so with this we have implemented the decision tree classifier model on a real world data set. And as you can see, like the other models, it's not difficult to be implemented, but as you can see, we have a case where we have an imbalanced data set, which impacts on the performance of predicting one of the classes. So we have a very good precision on the class 0, but very bad precision performance for the class 1. And these are the things that you have to play around and see how you can optimize, see what your algorithm is likes. So if you should have more training data set or more testing data set, introduce also cross-validation, which will select different samples from the population of our data set. So these are all things that you have to try and see by yourself, and that way you can understand how you can optimize your model. Anyway, thank you very much for following this video until the end, and I hope you liked it. See you in the next one. Bye bye.